Okay, good afternoon, everybody. Today I want to talk about something I'm really passionate about, Swift on the Arduino. More specifically, I want to talk about CoreAVR and ArduinoKits. More about them soon. But first off, who am I? As you already introduced me, I'm 21 years old. I live in Flanders, northernmost part of Belgium. I'm a software developer specializing in Swift and the JVM. And I am somewhat into rockets. A little bit. But then, what am I here for? I'm here for Swift for Arduino, which, as it says on the tin, has the goal of running Swift on the Arduino. And how do we do this? Two things. We have the S4A IDE, which is an integrated development environment specialized for building Swift for microcontrollers, along the MicroSwift toolchain, which is a specialized build of embedded Swifts made for AVR devices. It is actively being developed, which is always a good thing. But now let's talk about CoreAVR, which is a Swift-first AVR hardware abstraction layer. Well, try saying that 5 times. So it's a hardware abstraction layer for AVR chips. It is fully written in Swift. You might see the little asterisk there. Don't worry about it. And it is adaptable to other chips through Helgen, which is an internal tool we use to process AVR device files and transform them into a build of CoreAVR special made for that device. If we go a little bit more in depth into CoreAVR, then you might see a program like this, which is AVR libc. This is a simple PWM function written in C using AVR libc. PWM is pulse width modulation, for those who don't know, which is basically a fancy way of setting variable voltages or like analog writes to certain pins. As you might notice, there's a lot of magic values in this thing. And to be honest, if I didn't write this, I wouldn't even know what it does. This is what it looks like using CoreAVR, which is, in my opinion, a lot better. To give you a, thank you. To give you a bit of an idea what it would take for C to mimic a fraction of our power, you'd need a bunch of comments. Then it becomes a bit more readable, but still, the one on the right is cooler, I think. Of course, binary size is also important. If we take a look at what the C version takes up, then we're talking 174 bytes in total. The Swift version, it's not perfect, but I feel like 180 bytes isn't terrible. And yes, we are trying to bridge the gap to that those last 6 bytes. If you go a bit more in depth and think about something that microcontrollers do a lot, communication through UART, or serial monitoring, as some people might call it. Once again, this is what it looks like in C. This is what it looks like in CoreAVR. There's a bit more magic under the hood here, but and you can also see that in the binary size. C takes up 222 bytes. We take 534, which is not too bad, but we're trying to improve this. So don't really look at it. Thank you. Then, for a bit of transparency, CoreAVR, as well as our Helgen tool, are fully open source and licensed under MIT. You can find them there. You don't have to rush to take a picture of it. I'll show them at the end once more. Then the other thing, ArduinoKit, which is a bit of my child, is the Swift for Arduino standard library. It is a standard library for Swift for Arduino, and it is built on and fully exposes CoreAVR, which means that if there's a feature within ArduinoKit that you want to use, or if there's a feature you want to use that isn't in ArduinoKit, you can fall back to CoreAVR and do it yourself if you want. It is, once again, fully written in Swift. Don't look at the asterisk. Maybe I should explain what the asterisk means. It basically means, as you know, Swift is a safe language, and Oaking random data into random memory addresses isn't the safest thing to do, so for that we depend on C. But other than that, it's fully Swift. And ArduinoKit uses a so-called dual architecture, allowing both Arduino-style programs and Swift programs. More about that in a second. If you go a bit more in depth into ArduinoKit, this is an Arduino Core Blinky. So it's basically the first thing you do if you get an Arduino and open up the Arduino IDE. This is what you see. It is, yeah, it does its thing. It's stupid simple, and I like it. But we can do better. This is what it looks like in ArduinoKit, and most importantly, this is Swift. And as you can see, it makes a lot less assumptions than C does, because let underscore built-in output, high, low, I don't know, these could be anything. And Swift, we have clear enums, and it's fully type safe, and well, you can try to break it, but don't. Now, about the dual architecture, this is something I'm really excited about, because we're also thinking not about those who just want to use Swift or want to use microcontrollers. We're also thinking about people that are coming from Arduino but are interested in learning Swift. So we once more have our default Blinky program in ArduinoKit, or what I call Arduino default, but we also have Arduino Classic, which looks familiar. I can't quite put my finger on it. Oh yeah, it's basically the C version, but in Swift. So it allows you to, without changing a lot of code, to take your existing Arduino projects and use them in Swift. Now, for some additional transparency, ArduinoKit is also fully open source, licensed under MIT, and is available at this repository. And now I should address the elephant in the room. This thing. Of course it's written in Swift. What else did you expect? So this is running Swift, so if you don't believe me, well, you don't, but this is Swift. And that's all. Thanks for tuning in, and feel free to reach out afterwards. I won't bite. Thank you.